Delsan has been at the forefront of the demolition industry for decades, with a long history of successful projects. Only 2 years ago, they worked with Ontario Power Generation to implode the colossal decommissioned Lambton Generating Station. In the 2 years since the successful blast, the team has been hard at work on a new project that was previously put on hold, the Lambton Generating Station.
I'm Monica Dedick. I am the Senior Estimator Project Manager and the Assistant Project Manager on the OPG Lambton site. On site, we will be control dropping 4 boiler structures, 3 stacks, the North Stack, South Stack, and Wet Stack, as well as 2 SCR structures. The control drop will start with boilers units 4 and 3, then units 2 and 1. Once boilers 4 and 3 are control dropped, then the stacks will be control dropped one after the other. The last stack to be control dropped will be the North Stack.
My name is Paul Montero. I'm the Health and Safety Manager for Delsan AIM Environmental Services. From a health and safety perspective, this project brought in a lot of unique challenges that we never faced before. This is a very challenging job to this date. We've spent the last year pretty much just cleaning and abating and removing hazardous materials and demolishing some of the buildings that were left behind so that we can make room for the implosion that's upcoming.
Over the course of the last 11 months, Delsan has taken pre-blast site preparations to the next level. From the installation of C-can barriers and a reinforced fencing wall to help minimize the flying debris, to an extensive vacuuming out of all 4 boilers to reduce the fly ash after the blast. Delsan has also decided to leave the absorber building standing to protect a crucial switchyard that provides power to the community. As Delsan preps the site, their subcontractors, Rakowski Energetics, have already planned out the sequence of the blast and are installing their carefully designed explosives.
I'm Tristan Rakowski. I'm the owner of the Rakowski Group along with my 2 brothers. We're here today as Rakowski Energetics, which is our explosives division, preparing this project for Delsan AIM. The Lambton site's unique because all the structures are still standing. Most of the time we would all do this in a staged process where we'd maybe knock over the boilers and we'd follow up with stacks. But there are some challenges here with the way the site's orientated, our close proximity to other stakeholders, neighbors, United States border. So we've elected to do it all in one shot, one dust event rather than 2. So we have 9 separate structures that all need to come down, and we've sequenced them to come down in about 30 seconds. The sequencing is the most complex part of it. We have to detach those structures in a few milliseconds so that the boilers roll away. Then from there, we're actually attempting a new technique of walking a structure, which is walking the SCRs in a horizontal plane away from the stacks to open up a path for the stacks to fall.
My name is Ray Jambach. I'm with Englobe Corp. This is a big event. This is probably one of the largest projects we have done. We are confident that we've done everything that is possible. It's been engineered over and over, and we are confident that it's going to be a success.
So all these pipes here are is the boiler. So you got 4 boilers in total. Structure around it is just to house all the ductwork and all the exchangers and everything. So it's actually an independent structure, really. This is what's helping to support the boiler. These boilers are a suspended boiler. So the shape chargers are actually going to be installed on the flange of the columns. So it's actually going to be installed here on one side and also on the inside. That's why we did these cutouts here in the inside flange in the web. That'll cut the flange instantaneous, while the dynamite kick charge here will actually fling the column out of the way, which will then rotate and the whole building will crash coming down. This is the wet stack. This is the big one. This does not have an inner flue except for the 2 fiberglass ones inside. The walls are definitely thicker than the other stacks. And we have already drilled all the holes for the dynamite. And we're wrapping these ones up as well with the chain link to help contain the blast.
The Delson AIM crews have been working diligently for the last 3 months, preparing for the boiler structures, stacks, and SCRs to receive the explosives that will be used in the controlled drop of these structures. The crews are following detailed engineered guidelines and a blast plan to accomplish this work.
Everybody's doing their part, doing the tasks that need to be done. A lot of cleanup, a lot of double checking and making sure that everything is done properly. We have an on-site engineer that is constantly here full-time, checking to make sure that all the procedures are in place and everything's being followed.
The prep work required for this project is almost as daunting as the building itself. The boilers, SCRs, and stacks all require unique attention from the team.
So we're just back on boiler 1, putting the charges on right now. There's 4 columns that'll be blasted, 4 rows I should say of columns. Some of these bigger ones are so thick that we actually have to do double opposed charges, which means 1 on either side and the jet meets in the middle in order for us to cut the thick steel. One of the issues we have when deciding how to blast this, when you have construction on columns that are this large, when they're laminated like this, there's actually a couple issues that we have to address. One is that the overall thickness is simply too thick for us to find any product on the market that'll cut it, even when we put a charge on each side. The other issue is that when it's laminated and it's not one solid piece of metal, then anytime you ask an explosive jet to cut through there, that lamination significantly decreases the effectiveness of the explosive itself. In order to overcome that, Delson has removed the outer piece or scaled off the outer piece of steel, which allows us then to deal with the interior piece, which is something that the explosives on the market are able to cut. A layman can look at it and understand that it was built extremely sturdy, and the steel here is absolutely remarkable, how thick it is and how big it is, and it's really something. So to take it down is going to be a fantastic opportunity for us to showcase our skills at Rakowski Energetics, and then also for Delson, the overall project is a real feather in their cap.
I'm Bob Epps. I'm one of the team members here with Rakowski Energetics, and I'm part of the Rakowski Energetics United States division. The table behind me has some very interesting tools on it. So part of the dynamics of the Rakowski Energetics team is that we've brought some tools from another explosive industry into this demolition industry. And what we have is a bottle filled with a liquid, and we put a small amount of explosives in it, and it helps kick different portions of the beams out of the way to ensure that they are displaced and the building will fall. It is somewhat of a tedious process. We have to take the bottles, put a couple of pieces together, put a charge inside the bottle, and then make sure that it's filled with the liquid to the right amount, seal it so it doesn't spill, and then move it to the building and then place it in the structure accordingly. It's very complex and very unique, and the whole thing's going to take a matter of seconds to fire off, and then they'll all come down. I haven't seen very many jobs where this many things are coming down at once.
Rakowski also needs to install the explosives on all 3 stacks. To do this, a series of holes are cored out to fit the prescribed amount of explosives. But more focus lies on the wedge cuts at the base of the stacks. These cuts, designed by AIM Delson, are crucial to direct the fall of the stacks and only accept the prescribed amount of explosives. When the charges go off, the concrete wall will disappear and the stack will fall as planned.
Going good. It's very cold. For the international members of the team, it's far colder than we're accustomed to, but it's going well. We're having a good time. We're working hard, long days, but we're making good, steady progress every day.
How we set this up is we basically group together columns in 6 or 5 units at once. So that's what you see is this pink ring that goes all the way around. Between the groups, there's an interruption here. That is another detonator. So what happens is you're going to have a group of columns go off. Then this is going to be a 300 millisecond time delay before it fires the next group. So that snaps off, signal gets put in the box in 300 millisecond intervals all the way across. So that 4900 is already starting. So imagine after 4900 millisecond elapses, it's bang, 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 all the way across. Caps are cooking in the hole. Then the groups start energizing in 5 and 6 column groups, setting off the explosives. So mostly that's to do with to eliminate air overpressure. We're surrounded by a lot of homes.
When it comes to the implosion and dealing with dynamite and shape charges, there's a lot of health and safety related issues that we encounter. Not only the storage of the explosives, the handling of the explosives, ensuring that we secure the explosives, secure the buildings that have been loaded with dynamite and shape charges. So we've had to have 24-hour security, patrolling the buildings just to ensure that we keep the buildings safe for everybody, including the community around.
My name's Dave Dunsworth. I'm the worker health and safety rep. Our biggest thing is working at heights. We have everybody tied off 100%. We have the guys working up in the man lifts. Everybody's done their inspections on that. And we have a 1-week window. All our permits are in place. The local emergency services have been alerted. They've came in for their tour. And the Ministry of Labor's been on site. Everything's been inspected. Everything's been pre-planned. And I'm stoked and I can't wait.
On the day we're going to blast a building, we have to cover a vast area. So we were going to have to shut down a lot of roads and position a lot of checkpoints to ensure that nobody crosses the boundaries, as well as coordinating with the Coast Guard, considering that the St. Clair River has ships going up and down through the winter. We need proper winds, and that's anything over 20 kilometers an hour up to 30 kilometers an hour to perform this blast. The winds need to come from the northwest, and that's going to ensure that we are not going to have a dust cloud go over any residential properties or any properties that might be affected by the dust itself.
As the week progresses, the team completes the last of their cuts and places the last of their charges. The structure is ready to blast. However, the weather has different plans. The winds are not currently blowing in the correct direction. Even though the charges are set, this imposing facility must sit still and wait.
We got the weather that we were looking for. We have the wind directions that we were looking for. We have the degrees we were looking for. Guys, we're not gonna miss this window. We're gonna go for it. Tomorrow at 7:30, we're gonna blast. The last 2 weeks, we've been waiting for this day. We've been putting it back, pushing it back, pushing it back. Finally, we have the exact winds we're looking for, the speed and the degrees. Everybody have a good night's sleep, rest. It's going to be a long day tomorrow.
The blast is scheduled for tomorrow. So our main role now is the energetics team is walking the entire site, go and check every single connection. There's literally hundreds. Check every connection, make sure the wind hasn't made any of them come loose. Double check the charges, that they're all in place. The more times you can check it, the better. By the time blast day comes, there's really no reason that there would be any error with regards to the explosive setup. So at that point, it's just up to the explosives to do their job and the building to come down.
As the sun sets, the Lambton Generating Station completes its final day. Early in the morning, the team returns to activate the detonator.
Okay, so the weather has been consistently good.
Right now it is 311 at 26 kilometers with gusting winds, so we've got the winds we want. And I want to just ask OPG, are we good to continue with this?
Yep, I think we're good.
Fire department is ready?
Fire department's ready.
Okay. Tristan, the big guy.
Yes.
Are we good?
Yep, site has been inspected, we're go.
Okay. Good luck to everybody, and let's have a successful blast. Okay.
We got the police at barricade 3, Brian. We're gonna block her off now. 10-4, close off all the stations. Close off all the stations. All clear, station 1. Station 2, all clear. Station 3, all clear. Station 4, Station 5, all clear, boss. Station 6, yeah, I'm clear.
Station 7's all clear.
Station 8, all clear. Station 9, all clear. Station 10, all clear. Okay, Kareem, all the stations and all the personnel are all clear of the zone. Tristan,
Go for Tristan.
it's all yours.
Okay, thank you. St. Clair Fire Department, sound for 5-minute warning, 3 short blasts.
Roger, 3 short blasts, St. Clair Fire.
Four minutes. Tristan to St. Clair Fire, sound for 1 minute, 1 long blast.
Roger, 1 long blast.
All right, here we go.
Last 10 minutes in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. All stations stand by.
So we had a lot of moving parts on this blast design, and the goal was always to do this in one shot. It brought a lot of complications to it, the sequencing being the trickiest one. Having 9 different structures going in 7 different directions took a bit of engineering, and Delsan team and CSE did a great job. Once we have the initiation, you're watching all the detonations is what you're focused on, and making sure the buildings are rotating in the proper directions, and we had that. We had a little hesitation on one SCR. We had the charges go off, but we didn't get the penetration we were asking for. It was a very heavy column. It doesn't matter, the wet stack did wipe it out, so everything's good and safe. We're very pleased. It was a long 30 seconds, but again, the results are on the ground. The best team in Canada. Delsan and us share the same philosophies on site, and it makes them a real pleasure to work for. Very professional, very safe, and organized. Some of the best professionals in the blasting industry on earth here.
The blast went excellent. My heart was racing the moment when we started the countdown as I engaged the Energizer. You know, in 1 year work to prep everything, reduced to 30 seconds by a push of a button was unreal.
Beyond the sequencing of the blast and the strategic installation of the explosives, AIM Delsan's meticulous data analysis and diligent planning made this blast a massive success. The boilers and stacks fell as planned.
The blast was very exciting. It was a huge event for everybody. This plant meant a lot to this whole community for over 40 years. It was very exciting and somewhat bittersweet to see it come down, but they executed the plan exactly as we had planned it all, and I'm very happy it happened the way it did, in a safe manner, environmentally friendly manner. Delsan definitely has a professional attitude to everything that they do, and they have a lot of experience. They helped us decommission and demolish our Nanticoke site, which we're very pleased with their performance there, and they've done the same work here.
We
we look at it as a challenge, and there's just a lot of good stuff in there that we're going to go through, and it's part of the job. It's what makes this job fun. With all the green energy going on, recycling is definitely at the forefront of that, and we're happy to contribute. We have rail car access. We're going to be having trucks. We have a truck scale, we have a rail scale, we have a shuttle wagon. We load each car by material, by grade, to the destination that it's going, whether it's the mill direct locations, whether it's our recycling facilities in Montreal, Hamilton, Quebec City, to be broken down even further to be then recycled at other outlets.
You could say it's a mess, but it's actually not a mess. It's a very organized mess. Also, the stacks came down. We have to about 30,000 tons of concrete to process. We have to crush it to 2-inch minus, and that material is going to be reused on site to fill holes and level the site after we all done. The remaining structures that it's still there, we left them there for a purpose, to protect the switch yard that is behind those two buildings. Because if we shut down that switch yard, there would have been a lot of people mad at Delsan because they would have lost power in their houses. So that's the reason we left those two buildings there, just for protection. Once the boilers are moved out of the way, we are going to control drop them, but it won't be with explosives, it will be with our machines.
So just to wrap up, I'd like to give a thanks to all the OPG, Ontario Power Generation employees that worked here for over 40 years, all the employees who continue to work here, as well as all the retirees. We really appreciate all of the power and energy that they provided to the province over the past 40 years, which helped us build a lot of the industry and infrastructure we have in the province today. So big appreciation for all of that. Thank you.
When we look at, the implosion footage and we see how well executed it was and how everything went as planned, what a lot of people don't see is the work that's behind that in order to prepare the structure for that day. It's not just let's make an opening in a stack and drop the stack, or let's just put some charges in the building and implode the building. There's a lot of engineering that goes into that and a lot of planning as well. And in this case, like every other case we've done in the past, everything went as planned. We're very proud and happy that it was a success.